Hey everyone, welcome back. And today's topic is going to be the cross-region load balancer. That typically refers to the load balancing solution that operates across multiple Azure regions. Previously, we have seen while doing a deployment which was zonal, zone redundant, and everything was a regional component of the load balancer. Since we are talking about the cross region, that means the traffic is going to get diverted into the multiple regions. And the question comes, why do we need it? So there can be multiple scenarios where you want to consider the solution. So the first use case is going to be the incoming traffic, which basically originate from multiple regions. So you might have your application, which is going to be the distributed, and you want to really give a better user experience, which is going to be based on user proximity. So the traffic which comes from the internet, it goes to the load balancer, and then it get redirected to the regional public IP addresses. Those are configured for a regional load balancer. And you have option, you can put your workload in multiple regions based on your requirement. So there's an additional mark that indicates you can have multiple instances of public load balancer in multiple regions. Then the second use case, instant global failover. If this region fails for any reason, your traffic get diverted to the another region where you are running the workload. And here we are talking about layer 4 load balancer. So we definitely want to do the client IP preservation. And the another use case which I can think of is scale up, scale down behind a single endpoint. That means this IP remains same, and you have an option. You can perform some sort of the maintenance in these regions, or you can basically add or remove these workloads. And the whole solution basically works on static Anycast global IP address. That means this IP address, which is going to be configured on your cross-region load balancer, that will be announced from multiple regions as well. And top of that, you can build this solution with your existing load balancer solution. That means you might be running these load balancers already, and you want to put another layer of load balancer on top of that. Cross-region load balancer is not the only option to do a load balancing across multiple regions. There is another solution which exists and which we should know before we deep dive into this cross-region load balancer. So let's talk about Global Traffic Manager, because from Global Traffic Manager you can also achieve the same scenario where you can do the traffic load balancing across multiple regions. So what happens here? Anytime a user which is coming from the internet, it is going to do a DNS query, and that DNS query goes to your GTM, and then GTM is going to return those endpoints in response. And based on the response, user is going to initiate a direct connection to one of the endpoint, and it's completely based on DNS. However, you can achieve redundancy. You can do load balancing across multiple regions, but let's consider a scenario where you have recently updated the IP address of one of your endpoint in your traffic manager, but the client, they are still being redirected to the old IP address. And this issue is indicating some sort of the DNS caching at client end. So it depends on your application where you are looking for the fast rerouting and don't want to get into the DNS caching kind of the issue, then you are definitely going to choose your cross-region load balancing solution. there are a few more drawbacks which you can consider before considering any of the solution. Since this GTM based solution, this is completely based on your DNS infrastructure. So you need to keep in mind whatever the LDNS you're going to use from this user point of view, that is going to be considered as a attribute for your user proximity. It's not going to be the real IP address for the user. And if this is the IP address for the user and this is the IP address for the resources, you need to consider this latency as well. So all these drawbacks we are trying to solve when we go for the cross-region load balancer. Let's try to understand the key concept when you configure the cross-region load balancer. So a term which is called home region, this is where the cross-region load balancer or the public IP address or the global tier is deployed. That means when you are going to create your load balancer, these are going to be the home regions, and there are many home regions basically. So you need to ensure you are choosing one of them before you proceed for the deployment. And this region doesn't affect your traffic even it goes down. So traffic flow is going to be unaffected. Top of that, you are going to have participating regions, and that is where you basically do the advertisement of your IP Anycast to rest of your world. So these are again going to be many participating regions, and they help user to achieve better proximity. So anytime any traffic which is originated from any of the user based on IP Anycast, it is going to be closest participating region where you basically enter into your Microsoft infrastructure, and from there over the backbone you travel to the resources wherever you have deployed. Let's try to understand more in detail. So for example, the moment you deploy your cross-region load balancer, you're going to choose one of the home region, and these regions comes from here. This is a list. So for example, I have deployed my load balancer here, which is going to be the global tier. And for any reason, this region goes down, it's not going to impact your traffic. Your traffic will continue to flow because the way it works, let's consider this is a user. It will be connected to some sort of the router, and from here you will be doing your peering with this service provider, and you will be running BGP, that is going to be the internet protocol, and this will be paired with your Microsoft infrastructure. So based on the best route, it will take you to the nearest participating region where this Microsoft is available. And once you enter to the participating region over the Microsoft backbone network, you will be traveling to wherever you have deployed your load balancer resources. And rerouting will happen. For example, if this also fails, you may have another load balancer which is deployed here. So this participating region, it will take your traffic to the next available resources. So if the home region goes down, you will not be able to alter any of the configuration. The configuration remains same, and it won't impact your traffic flow. So this is not part of your data path. And here I'm quoting a Anycast IP address. So the moment you deploy your load balancer, this global tier IP address, this is just for the example, will get assigned to your configuration, and this IP address will be further being originated as any cast from all these participating regions. Let me clarify a bit more in this diagram, which may make more sense to you. So we will start from bottom line, which is going to be your original deployment for the load balancer. So let's take example. This is region, maybe it's a US West, and this we can consider US East. These are the regions where you have deployed your load balancer. So you have one deployment, second deployment. This is going to be the pool where you have the workload. This is again going to be the pool for this region. And these are connected with your Azure cloud infrastructure, since everything is a part of the global Azure cloud infrastructure. On top of that, you can consider another layer, which is going to be the global tier, global cross-region load balancer, and which contains participating region, it contains home regions, and there are many. So consider this is a load balancer which is available across all the participating regions. So anytime a user traffic which get generated from anywhere based on the local peering, it will find the nearest Microsoft Azure, POP, or maybe the Edge data centers, which is advertising IP Anycast. And once you enter to Microsoft Azure infrastructure, it is going to redirect all this traffic to the nearest region where you have your workload deployed. And that is going to be the based on the algorithm, and that algorithm will give you the best user proximity. So it will consider the user IP address, and it will consider where you have your resources deployed. Hope it make more sense. And in the next session, we will talk about the lab. Thank you for watching, and I will see you in the next section.